Welcome, ladies and gentlemen, to Watch It Print. And this is the very first in a series of videos where I'm going to be working with my Ender 3 here to level up its printing capabilities. Now, this little unit here has been a nice little workhorse that I've been playing around with for the last week. And as you can see, it does PLA absolutely awesome. This is a Baby Groot, and this Baby Groot was printed over 34 hours at a layer height of 0.08. And you can just see the immaculate detail that this printer has been able to reproduce of that model. Just absolutely awesome. I mean, look at just the end of the foot there. Oop, 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 come on. Look at that. I mean, just absolutely ridiculous. However, it doesn't do well with all materials. And some materials it actually doesn't do at all. There's some problems. It has a limited temperature that it can get up to. At 260 degrees is what the maximum you can actually set it to. Now, safely, the maximum you can really run it to is right around 245, 250, which is good enough for, let's say, Tallman's 3D Alloy 910. This is a nylon blend, nice and high grade. I use this at work quite a bit, and I also use it for some parts on one of my other 3D printers. Really good material. Takes about 255 degrees Celsius in order to get excellent layer bonding. And the other thing is that it also does not like part cooling at all. You can actually kind of see the material as it's coming out of the 3D printer onto the part, and it'll kind of go from a layer and then it'll kind of gloss. You kind of lose its shiny and to get a little bit dull, and that's when the next layer can be applied. But if it gets too cold, you're going to have poor layer bonding. And if we take a look at this printer, you can see that it's pretty much like a mini CR10. As a matter of fact, I think this is the exact same Hotend on a CR10. And while this thing does an absolutely great job of, reproducing PLA or making parts in PLA, it has one key problem that I don't really like, and that has to do with this fan right here. One, there's a fair amount of vibrations in this fan. The other thing is some software settings. This fan is pretty much just always on from the moment where I actually turn it on. You can see here, I'll flick it on, and right off the bat this thing is running, even though the hot end isn't on at all. The hot end is 23 degrees Celsius. Now, my biggest gripe with this hot end cooling fan isn't that it actually cools the hot end or just continuously runs or anything like that. It's that it's always doing a little bit of part cooling. If you look down here, and I get down real low, there's a gap between this shroud where the fan kind of is mounted to and where the hot end heater block begins. And through there, a bit of air escapes. And if I put my finger right down here, there's cold air blowing on it right now. And the part fan over here, that's not running at all. I mean, it's just it's off. There's just a little bit of blow-by that's happening from this muffin fan right here and the radiator, and it's blowing out right near the nozzle. So that's not good for ABS. It's not good for nylon, especially if you're doing a larger part and you got to maintain a little temperature on that previous layer to get good layer adhesion. Or if we want to do something like PC Max, from Polymaker, which has a temperature of 250 to 270 degrees Celsius and absolutely does not want any sort of part cooling in order to get, really good layer adhesion. You just cannot have a part cooling fan running at all. So this design here has got to change. Now, there's a lot of great different modifications out there on Thingiverse that you can take a look through, but I want to go through this and create my own because I also want to teach you how to turn an idea into a part and be able to actually go through the whole process of the engineering process to develop our own hot end, because this is a learning experience, not just trying to make a better hot end. Hopefully you guys will learn something from this process that'll be a very useful skill in the future. So this is where the first part comes in. This is a miniature blower. Now, this thing's actually used on some other 3D printers out there, I believe on Deltas and whatnot, and all it is the size smaller of the blower fan that's on the side of the unit over here. If we take a closer look at what's behind this fan shroud, what we'd find is a heating element just like this. So this is our hot end. It has just a normal sort of airline fitting up top. We also have our radiator down here. That's going to be where we keep the heat break that's inside of here cold enough so that our filament doesn't turn to mush before we get to the heater block right down here. And beneath that is the part that we know and love, which is just kind of the nozzle where all of the filament comes out. Inside of this heater block here, which is just a chunk of aluminum, you have your ceramic heater usually. So this is either 12 volt or 24 volt. In our unit, it's going to be 24 volts. And then next to that is a thermistor. Now all of these hot ends are pretty much the same thing, no matter if they're really cheap or quite expensive. So if I were to compare this one to one that's styled after the E3D V6, you'll notice that it has a little bit different. So this one obviously has the same sort of heater cartridge, but the thermistor, comes enclosed in a piece of metal like this, as opposed to just being kind of like a little glass bead, which you have in this one. It's the same exact stuff. It's just packaged a little bit differently. The one key change that we're going to make to this unit here is a higher grade PTFE lining that claims on their website quite boldly that you can run up to 300 degrees Celsius with a PTFE lining. So that would make it really useful for us that we can run temperatures that are hot enough to run something like our PC Max, which requires 250 to 270 degrees Celsius. Without having to go to an all-metal hot end, which causes some problems when you start doing things that are really complex on PLA, because PLA likes to stick to the walls if they're metal. So if you end up having like lots of really rapid little retractions, there's a good chance you can get a clog in the hot end itself, which kind of makes it a pain in the butt to go all metal. So I'll be testing that out as well, to see if you actually can go up to 300 degrees Celsius and if it stands up to the test of time. Okay, so now we know what we have to do and why we're going to do it. Let's take a look at how we're going to do it. So this little fan here has one advantage because it's a blower style, and blowers, compared to like these muffin fans, are really good at creating static pressure, which means you can force air through smaller gaps. It doesn't necessarily move as much air, but it does it better in confined spaces, which is exactly what we have going on here, which means a blower would be a better option than a fan like this. However, as you can tell, it has another kind of different requirement in that the air comes in the front here and usually gets blown out the side, as opposed to coming in the front and blowing out the back. But the key thing we need to do here is actually change the way that the air is exhausting from the hot end. So what I'm going to do is take this little blower, flip it around so that it's, the fan side itself, the inlet side, is facing the radiator like this. So how this thing is going to be arranged is the hot end is going to be here, and then I'm going to take the inlet side of the fan and face it against the radiator like this. I'll actually keep a couple millimeters gap, and that will keep the noise down, because if you place this really, really close, you'll end up getting some noise because those blades are just so close to another surface. But that'll create a nice good suction, bringing cold air in across the radiator and then exhausting the hot air up and away from the part. And the reason that I think this is going to work out really good is because I actually use these blower fans quite often in my job, where I design vacuum conveyors for part holding, and we end up using blowers, but they would not work at all with a muffin fan kind of like that, or an axial, or whatever those fans are called. Blowers work great for this. I also heard a saying that it's a lot easier to remove heat than it is to add cooling. So that's exactly what we're going to do here. And when I go to test this, I have a bunch of different thermistors that I'm going to put on this heat break itself to see if we've made an improvement in how cold we can keep this thing versus stock. So I won't be guessing. We'll actually do some real testing and science and stuff with fancy graphs to make sure that this is going to work out and work out well. Now here's the cool part. If we take this unit, we already have a bolting surface here, so we can take yet another fan and mount it like this with a duct that goes down across the heater block and around the nozzle. So we can actually get 3 to 4 sides, or pretty much the whole side cooling on this nozzle, and the duct goes right from here to the nozzle. So it's not big at all. It's very, very small. The whole thing is only about as wide as the heater block itself. making this a very, very lightweight, compact unit. So the advantage of that is we're going to take the mass of our hot end and we're actually going to reduce it as compared to the stock unit. So, you know, in this arrangement here with the bed moving back and forth, the bed is our limiting factor. But if this was a Core XY unit, so basically this whole bar system, if this was laid horizontally and we're moving the hot end around on it, that would be a lot smaller mass to accelerate and decelerate and change direction than what we currently have. But wait, there's one more modification we can make to this hot end to improve it just a little bit more. So taking a look at this unit, you can see that there's something weird going on. And that is that the carriage that runs back and forth here is, the center of the carriage is right here, the hot end is off to the right, and the whole thing just kind of looks lopsided. So we're going to correct that, and we're pretty much going to center up that hot end, which is going to allow us to, you know, basically keep the nozzle off the platform. In my case, you can see that right over here is that line is where it homes when it goes all the way back. So when this is all the way back, for whatever reason, my nozzle is still over the platform. So we're going to get that off the platform on both ends of the printer by just moving that nozzle over. We'll center up that mass on the carriage, and we can also reduce the carriage's overall width and change its material from metal to a lighter weight plastic. Once again, reducing the overall mass and kind of reducing the amount of vibrations that are experienced on the printer itself. All right, so we talked about a lot of stuff. Let's recap real quick. We're going to improve the software so that the fan doesn't stay on all the time, only when it's at a temperature that when it should be on. We're going to change the way that the hot end cools itself, so we'll be removing the accidental part cooling that is happening right now. We're going to change the way the shroud works for the part cooling fan so that instead of just being one direction, it'll be on 3 directions, and it'll also be in a much smaller package. We're going to improve the materials, which reduces the weight as far as what the hot end is mounting to, and we're also going to increase the overall temperature range, hopefully up to 300 degrees Celsius without, you know, causing any extra wear and tear on the lining material inside of there. So that's 5 major improvements that we can make to this hot end to really increase the capabilities of our Ender 3 3D printer.